So PPT is visible. Yes. Okay. So in last class we discussed the definitions, which are graph, what is tree, what is node, so what is a loop, and what is core and what are the different types of subgraphs. Okay. We will see today what is incidence matrix. So these all are completed. So why this network topology will be used? So in this network topology is useful for solving the complex electrical network. Right? If you're having a big complex electrical network, so by using nodal analysis and mesh analysis, we cannot solve. Why? Because there will be so many equations you will get. Right? So if you are having 7 nodes or 10 nodes, so then at each node you have to write one nodal equation. So by using nodal analysis, and you have to solve the 10 nodal equations. So that will be a complicated process. So for such type of networks, so which are complex, we will use this network topology. So network topology you can also call it as a graph theory. So here we will represent the electrical networks in terms of equivalent graphs, right? Simply by replacing all the passive elements with line segments, and the voltage sources are short circuited and open circuited the current sources. Okay. So if you see here, this is the electrical network and its equivalent graph is this one. Here you are having the these elements. Here you are having the these resistors here. These resistors are simply replaced with a line segment, and this voltage source, which is between 1 and 4, it is replaced with short circuit. But the current source, which is between 3 and 4, is open circuited here. Right? Here you are not connecting the current source, right? So in the graph, this current sources will be open circuit. So if you observe the total number of nodes present in the graph, so the total number of nodes present in the graph will be same as the total number of nodes which are present in the electrical network. So but if you observe the number of branches in the graph, these will be generally less than or equal to the total number of branches in the electrical network. If there are current sources, in such a case, the branches in the graph will be less than the electrical branches in the electrical network. If there are no current sources, then total branches in graph will be same as the total branches in the electrical network. Okay. So here these are the definitions. This we already seen the last class. And types of graph.
వాయిస్ రావట్లేదు.
లేవు.
Excuse me, sir. Sir, you're muted, sir.
Oh, okay, sorry. Right. Is it visible now?
Yes, sir. Yes, sir. Yes, sir. You're audible.
Okay, right.
Yes, sir.
Planar graph, if you draw a graph on a plane surface or a plane paper, you will not get any crossovers here. Okay. So then in non-planar graph, you will generally get the at least one crossover. So here subgraphs and its types. So a subgraph is nothing but it is a part of graph. Okay, by taking some nodes and branches you can redraw the graph. So such type of graph is called the subgraph, right? In subgraph, you may not have the all nodes and you may not have the all branches. Okay. So and these subgraphs will be having a number of nodes which will be less than that of the original graph, and number of branches also will be less than that of the original graph. So you can say that a subgraph is nothing but it is a subset of the original graph. And there will be two types of subgraphs are there, which is called tree and co-tree. Okay. So if you see the tree, this tree is a connected subgraph. So connected subgraph in the sense, it is a subgraph. So that means it will be not having all the branches, which will be same as the original graph. Okay. So it is the subset for the original graph. And connected here is in the sense, so it will be having the all nodes present in the original graph. Okay. So tree is a connected subgraph, and connected subgraph here in the but if you take a subgraph from the original graph, and in such a case, all the nodes present in the subgraph will be having at least one path between any two nodes. Okay. There is no isolation here. So as we see in the non-connected unconnected graph here, so one node is isolated here. So such type of tree will not exist. Okay. So tree is always a connected subgraph, so which is drawn from the given graph, right? So it will contain all the nodes of the graph, but there should not be any loop present in the subgraph. Okay. So simply it is nothing but tree is nothing but it is having all the nodes of the graph, but no closed loop. So you see here, this is one tree, so which is taken from the original graph, this one. So let us assume that this one is the original graph. Okay. So now from this we are taking a tree. Okay. So with the DEF elements or DEF branches. Okay. So this here you draw the word tree here. So with the DEF. Now if you observe this tree here you are having all the nodes 1, 2, 3, 4. All the nodes are present, but there is no closed loop. Okay, in a tree you will not have any closed loop. Okay, so now the branches in the tree, so which are DEF, these are called the twigs. The branches of a tree are called the twigs, and the number of branches present in this tree will be one less than the total number of nodes. If there are n number of total nodes, then the total number of branches will be n minus 1. So co-tree. So co-tree is also a subgraph, right? And this co-tree will be formed by connecting the branches which are removed while forming a tree. Okay. So while forming this tree, we were removed some of the branches. Okay. So those branches here from the original graph are B, C, A. Okay. So B, C, A are the removed branches while forming a tree. Okay. So while forming a tree, you can remove some branches. Those branches, if you take and connect again, so that subgraph is called the co-tree. Okay. So co-tree is nothing but it is a subgraph which is formed with the branches that are removed while forming a tree. Okay. So it is also called as a complement of a tree. Now if you see the figure here, so with BCA, so we are forming a co-tree here. So co-tree is a subgraph of the original graph. Okay. So now in co-tree, the branches will be represented with the dotted lines, and these branches are called the links or cords. Okay. So now, so these are the branches which after forming a tree. Okay. So if you observe the total number of branches in a tree, or those are called the links. So the total number of links will be is equal to total number of branches in the original tree minus total number of branches while forming a tree. So which is nothing but n minus 1. Okay. So see here. So you are having B branches. Right. So let us assume that there are B branches. Total number of branches will be B in a original graph. So this is original graph is having B number of branches. Now while forming a tree, you will take only some of the branches. Okay, right? So those are called the twigs, right? So now the total number of branches in a tree will be 1 less than the number of nodes, which is n minus 1, as already told in the previous slide. Okay, n minus 1 is the total number of branches in a tree. So now in a core tree, right? So how you can form the core tree? So you will form the core tree by taking the branches which are removed while forming a tree. So this total branches in the core tree will be b minus n minus 1. You have to subtract n minus 1 branches from total number of branches in the original graph. Okay, so these are the n minus 1 branches which are formed a tree. Okay, if you remove those, you will get the remaining branches in the tree, right? So these branches in the tree are called the links. So it will be represented with L. Okay, so L is equal to, so total number of branch links in the core tree will be b minus n minus 1, or it can be written as b minus n plus 1. Okay, now let us see the incidence matrix. Okay, so till now we already discussed in the previous class. So now here today we will see the incidence matrix. Okay, what is incidence matrix? Now if you observe a graph, so in the graph every element will be incident between two nodes. Okay, so if you take any branch, right, any branch, that branch will be incident between any two nodes, right? If you take an example here, so this graph, okay, so now in this graph, if you take branch 5, so this branch is incident to node 1 as well as node 2. So right, so this branch is in between 1 and 3. So if you take the branch 3, so branch 6, it is between nodes 1 and 2. So like that, every element or every branch in a graph will be incident between two nodes. Now the information which tells about all the elements in a graph is represented with one matrix, which is called the incidence matrix. Okay, this incidence matrix will tells about the information of all the elements which are there in the graph. Okay, and all those elements are how they are incidents. Okay, so let us see the first one, element to node incidence matrix, so which is represented with a bar here. Okay, so now this element to node incidence matrix describes whether an element is incident to a particular node or not. Okay, so while forming this element to node incidence matrix, you have to remember these conditions. Okay, how you can form the matrix here, right? So this matrix, let us say take a bar is a element to node incidence matrix. Okay, and this matrix order will be total number of elements and number of nodes. Okay, so order is E by M. Okay, total number of elements you have to represent here, and total number of elements is nothing but branches now. Okay, elements or branches both are the same. Okay, so you represent these columns as elements and rows as nodes. Okay, so these are branches or elements. Okay, so now if you take this example here, so now while forming the element to node instance matrix A bar, so you have to take the branches or elements as columns. So this is how many branches are there here? 1, 2, 3, 4, 5, and 6. 6 branches are there. Those you represent here. So 1, 2, 3, 4, 5, 6. 6 branches will be represented like the columns. Now rows here, sorry, these are the rows, right? So these are the rows. So branches are represented as well. Now columns will be your nodes. How many nodes are there here? So this is node 1, this is node 2, this is node 3, and this is reference node or 0th node. Okay, so you represent them. So this is 0th node, this is first node, and this is second node, and this is third node, like that. Okay, so now here you have to represent the elements of your matrix. Okay, so how you can represent these elements of your matrix, right? So now here, so if you take Aij, so is an element in this matrix. Now, so the Aij value will be equal to 1 So Aij value equal to 1 if ith element is incident to and oriented away from the jth node. Okay. So now if you take particular element here, let us wait for something. So we'll remove this all. Okay, right? So here, while forming the elements, so now for this element to node incidence matrix, the value of Aij, so it will be equal to 1 if ith element is incident to jth node. Okay, and it is oriented away from the jth node. Okay, suppose here you take this one. Okay, so the element is 1 or branch is 1. So this branch, now this branch is incident between 0th node and first node. Okay, so this branch 1 is incident between 0th node and first node. Now this direction of this branch current will be away from the 0th node and towards the first node. So here, when it is away from the node, you take it as a +1. So if it is towards the node, you take it as -1. Okay, so now here you are having 0th node, and here you are having node 1. Now this component A, so this component you can call it as A10. So between 1 and 0, right? So now as it is away from the node 0, you can represent with +1, and it is coming towards the node 1, you can represent with -1. Okay, so when it is away from the 0th node, that 0th node will be represented with 1, and it is towards the node 1, so here you will represent with 1. Now this node, this branch 1 is not incident to any other nodes. Okay, it is not connected with the second node and third node. So at the second node and third node, we are keeping it to be equal to 0. Okay, so like that you have to represent for all the elements. Now you take the second element or second branch, this one. Now it is incident between 0th node and second node, and away from the 0th node. So at 0 node +1 you have to keep, and towards the second node. So at the second node you will get -1, and it is not incident to first node and third node. So here you are getting 0 and 0. At first node and third node you will get 0. And if you take the third element, the third element is this one. It is incident between 2 and third nodes. So and it is away from the node 2. So at node 2 you will get +1, and towards the node 3, at node 3 you will get -1, and it is not incident to node 0 and node 1. So here at node 0 and node 1 you will get zeros. Like that. Is it okay, ma? It is understood? So this logic you have to follow. Aij is equal to 1 if ith element is incident to and is oriented away from the jth node, and this Aij value will be -1 if the ith element is incident to and oriented towards the jth node, and Aij value will be equal to 0 if the ith element is not incident to jth node. Okay, so you will be given, after forming a tree, you can easily form the element to node incidence matrix. Okay, so now here reduced incidence matrix or incidence, simply you can call it as incidence matrix, which is represented with A. Okay, so this incidence matrix A you can obtain from the this element to node incidence matrix. Okay, how you can obtain? By simply removing the reference node column, right? By removing this reference node column entirely, so the remaining matrix so obtained is called the incidence matrix or reduced incidence matrix. Okay, so reduced incidence matrix is nothing but, so this is the matrix obtained by deleting the column which is corresponding to the reference node. Okay, so here we were formed the element to node incidence matrix, and we are removing the reference node column. So this entire column we are removing, and the remaining matrix so obtained is called the reduced incidence matrix, or simply you can call it as incidence matrix. Okay, So in electrical terminology, you can even call it as a bus incidence matrix. Okay. So that means simple ma. So if you are asking for incidence or reduced incidence matrix, we are not going to consider this zeroth node. Okay. So while writing A, so all the elements will be represented as rows. So branches will be 1, 2, 3, 4, 5. 5 branches are there. Then columns will be, actually you will represent columns as nodes. But while writing here, you should not take 0. So you have to take only 1, 2, and 3 only. Okay. So now you form a matrix here. Now if you take the first element, this first element is between 0 and first node. Okay. So at first node, it is towards the node. So here you will be having -1. And it is this one is not incident to second and third node, so it will be 0 and 0. And if you take the second node, second element, the second element is toward the second node. So toward the second node means here you will get -1, and it is not incident to first and third node. So here you will get 0 and 0. Right? If you take the third element, so the third element here is between 2 and 3, and it is away from the second node. So away from the second node is positive. Towards the third means -1. And not incident to 1 means 0. And fourth element, this fourth element is between 0 and third. 0 we are not considering, so it is, you have to consider only the third node. So and direction will be towards the third node, so it will be -1. So remaining 2 and 1 will be having zeros. And if you take the fifth element, it is between 1 and 3 and away from the 3. So away from the 3 means +1 here, and towards the 1 means -1 for 1. So it is not incident to 2, 0. And you are having the sixth element also. That sixth element is between 1 and 2, away from the 1. So at 1 you will be having -1, and towards the node 2. So it will be at node 2, it will be positive, and it is not incident to third node, so it will be 0. So this is the reduced incidence matrix. Okay. So here we are not forming the matrix without this reference node. So with this reference, we are not forming the matrix with 0 node. Okay. Only you have to consider the independent nodes. Reference nodes we are not going to consider.
Sir, in last case at the sixth element, sir, it is going away from node 1, sir. Then it should be positive 1, right?
Right. Sorry. So this is positive, away from the node positive, towards the node minus. Right, correct. Okay, so like this you have to form the reduced incidence matrix. Okay, so so you were asked to find the element to node incidence matrix. In such a case, you have to take all the nodes, including the reference node. But while forming the reduced incidence matrix, you have to eliminate the reference node. You have to form the matrix only with the independent nodes. Okay, right. Let us see some examples so that we can understand. So now this is the network given, and you have to draw the oriented graph for the following network. Okay, so now oriented graph they are asking. So now you observe this network, and how many nodes are there? So here one node, here one node, here one node, and this is one node. Okay, so total 4 nodes are there. So number of nodes will be 4. Okay, so now you take them as it is. Here you are having the 8th node, Bth node, and Cth node. Then you are having the Dth node. Okay, so now you observe the elements. So between A and B, you are having the inductance. So all the elements will be replaced by line segments, right? So voltage sources will be short circuited, and current sources will be open circuited. So here in this circuit, you are not having any current sources. You are having the voltage sources. These voltage sources all are short circuited. Okay. And all the passive elements in the here is nothing but resistor, inductor, and capacitor. Those passive elements will be represented with line segments. So now between A and C, A and B. So first you are having the inductance L1. So that is represented with one line. So between B and C, you are having second inductor, which it is represented with the line segment. And between B and D, you are having the resistance, which is represented with one line segment. Okay. And between A and D, you are having capacitor in series with the voltage source. Voltage source is short circuited, and capacitor will be represented with the line segment, so that you will get another line between A and D. So here between C and D also, you are having 3 elements here. All the elements will be represented with lines only. So again, you will get only one line. Okay, and here between A and C, you are having resistance R1 in series with the voltage source V2. This is short circuited and this is a line segment. So again, you are having a line between A and C. So now this is called the graph of your original network. Okay. So now this is a graph simply, right? Again, these graphs, if you observe, it is not having the direction of currents. Okay. So these are, if you observe that these are elements, these are the branches of your graph. Okay. So each branch you can represent with numbers 1, 2, 3, 4, 5, 6. So this numbering is your wish. Okay, arbitrarily you can select the numbering. Okay, now this graph will become the unconnected graph. So unoriented graph, unoriented graph. So why? Because we are not given the any branch, any direction for currents which are flowing the each branch. Okay, direction of current in each branch is not represented here. So it is called the unoriented graph. So but they were asking the oriented graph. Okay, so when they are asking the oriented graph, you have to represent the directions. Okay, so the direction for these is again arbitrary. You can take any direction. So you simply represent with some direction in each branch. Now it will become the oriented graph. Okay, so this is the solution for this problem, right? So they are asking draw the oriented graph for the following network. Okay, after drawing the graph, you have to represent the direction of current also in each branch. Okay, that the direction of current will be arbitrary. You can choose in any direction. Okay. Okay. Right. So the second one. So for the graph shown here, write its incidence matrix. So now here you need to write the incidence matrix for this graph. Okay. So incidence matrix, they are asking the incidence matrix, not the node to element to node matrix. Okay, incidence matrix is nothing but A. Okay, element to node incidence matrix means A bar. So while writing A bar, you have to consider the all the elements. Okay, you have to consider all the nodes, so including zeroth node. Right. So here, if you observe this network, you are having node 1, node 2, node 3, and node 4. So here we are not having the 0. So, but you can while writing element to node instance matrix A bar, you have to take all the nodes 1, 2, 3, and 4. All nodes you take, and branches are represented here with A, B, C, D, E, F. So branches have column A, B, C, D, E, F. Right. So now this matrix is called the element to node instance matrix A bar. Why? Because we are taking all the nodes here. 1, 2, 3, 4. All the nodes we are taking. Okay. So now if you remove one node, so that will become the reduced incidence matrix or matrix A, incidence matrix. Okay. So which node I have to remove? So that is your wish. You can consider any node as reference node. I can take 1 as reference node. I can take 4 as reference node. Okay. If you take 4 as reference node, so now you remove the column of this entire 4th node. Okay. Right. First, you form the element to node incidence matrix. A bar you form. So with all nodes. Now here, if you observe the A, so this A is between 1 and 3 here. So between 1 and 3 and away from the 1. So here you will get +1 and towards the node 3. So here you will get -1 and it is not incident to second and fourth nodes. So here you will get 0 and 0. And B, branch B is between 1 and 2 and it is away from the node 1. So +1 for node 1 and towards the node 2. So it will be -1 for node 2 and it is not incident to third and fourth node. Okay. So then if you take the branch C, so this branch C is between 2 and 3 and away from the 2 towards the 3. Away from the 2 means +1 here, towards the means -1 here, not incident between 1 and 4. And D is between 1 and 4. So away from the node, so it is positive. Towards the node, it is negative. So it is not incident to second and third. So now element E is between 2 and 4. So away from the 2, so here positive. At 4, it is towards, so it is minus. So remaining node, it will be 0. F will be between 3 and 4. So at 3 it is away from, so it is positive, and 4 it will be negative, minus 1. So remaining zeros. So this is the element to node instance matrix. Element to node. So why? Because we are taking the total number of elements E and total number of nodes N. So this matrix is having the order of E by N here. Okay, element to node instance matrix is having an order of E by N. So now they are asking the incidence matrix A, right? So this incidence matrix will be having the order E by N minus 1. You have to subtract one node, which is the reference node here. Okay, so now in this circuit, which node you have to take reference node? That is your wish. So one can take 1 as reference node, other may take 2 as reference node, some other will take 4 as reference node. Okay, so now I am taking 4 as reference node. So in such a case, I have to remove this entire 4th node, and you have to represent the remaining matrix, which is called the incidence matrix A. Okay, so this A will be having this matrix. So the order will be E by N minus 1. So N will be here, total number 4. So this is 3, and total branches will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 elements. 6 by 3 will be the order for this incidence matrix. Okay. Understood now? See here. So we are representing the node. So మీరు ఇక్కడ రివర్స్ చెప్పారు, రివర్స్ రిప్రజెంట్ చేశారు. You can even take the nodes as your rows, branches are your columns also. So that is also not a problem. Okay. So first draw the incidence matrix, reduce element node matrix. Then you remove one column so that you will get the reduced incidence matrix, which is called the simply incidence matrix. Okay. So let us see another problem here. So for the following network, draw the graph, connected graph, tree and co-tree. Okay, so this is the network given. So for this network, you have to draw the graph. Okay, so while drawing the graph, all the passive elements will be represented with line segment. Voltage sources short circuited, current sources open circuited. So here, if you see, you are having one current source. This will be open circuited. Okay, with the remaining elements, you have to form the graph. So 1, 2, 3, 4 nodes are there again here. So we are represented here 1, 2, 3, 4. Now between 1 and 2 you have one element, 2 and 3 you have one element. So this is represented here in this. Between 2 and 4 you are having one element with the line segment. This voltage source is short circuited, so you will be having another element. And this with this resistor you will be having the another element. Between 1 and 3 you are having the another element. So this one total your graph is this one. Okay, so this is the graph, which is also called as a connected graph. So why? Because so there is no node which is isolated. Okay, in such a case you can call it as a connected graph. Okay, so graph on ide, connected graph on ide. Okay, suppose they are asking the oriented graph, so then you have to represent the directions for this, so which is arbitrary here. Okay, now this will become the oriented graph. Now how we can form the tree? So what is a tree? So this tree is having all nodes. A tree is having all nodes and no closed loop. You have to select some branches such that there is no closed loop in a subgraph. So this tree is a subgraph which is having all the nodes of the original graph, but no closed loop. All the nodes here is nothing but you have to take all the nodes 1, 2, 3, and 4. Okay, this is first node, and this is second node, and this is third node, and this is fourth node. Now you have to select the branches such that there should not be any closed loop in the this subgraph. So I am taking D, E, and F. Okay, the D, E, F branches. With the D, E, F branches, you are not forming any closed loop here. So in such a case, it is called a tree. Okay, this is one tree. So some other person will take some other branches, right? You will take all the nodes 1, 2, 3 for all the nodes you take. Okay, and some other person will take the branch this one, and branch this one, and branch this one. So here also there is no closed loop. So this is also will become a tree. Okay, so here in the graph, trees are not unique now. Okay, from original graph, you may be having so many trees. Okay, so this is one tree. If you select D, E, F as your branches for a tree, and if is another tree, if you select A, C, F as another, say A, C, F branches, right? So in both the cases, we are having all the nodes and no closed loop. Okay, so like that you will be forming many number of trees, right? Right. So here are the total number of trees which you can form from the graph. Okay. Some other person may take these three branches. Okay. So like that. So the trees is not unique. Okay. If you observe all these subgraphs which are taken from the original graph, so all these graphs are having all the nodes but no closed loop. So everyone will become a tree. Okay. Now what about the core tree? So now if you are taking a tree here with the branches E, B, E, F, and you are removing this branch B, branch C, and branch U, right? So B, C, A are removed while forming this tree. So now core tree is